you guys have done a lot of so you want to play guitar, but you think to yourself, I could never do that. And you think learning is boring and dry. Here's the deal, it doesn't have to be.
This is what a red cabbage looks like. Blunt force trauma. In order to extract the anthrocyanin, we're going to use 70% ethanol acidified with acetic acid. And instead of boiling, as most people show this to be done, I'm going to be using ultrasonicator. This will prevent the anthrocyanin from degrading from the heat. However, I will be applying some heat, maybe 40-50 degrees. But before we do any of that, we need to wash the surface. Here is 1/2 of a red cabbage. Quite amazing looking. Next we transfer the cabbage to a colander. We want to rinse the cabbage under cold water. No pesticides or dirt. We take 300 milliliters of water, distilled water, followed by 700 milliliters of ethanol. This will make 70% ethanol solution. 250, 250, and another 200. For the last step, we want 10 milliliters of acetic acid. This will give us our acidic ethanol solution. This will be our extraction solvent. I am now preparing the ultrasonicator by heating up water inside to 40 degrees. Our solvent is thoroughly mixed and our cabbage will go into a blender. And now we can add our extraction solvent. This process breaks down the cell walls, aiding in the next step. Now, we fill one beaker to be ultrasonicated. I will be running the ultrasonicator at 40 kilohertz. Next, we're going to perform a gravity filtration using my new funnel. First, we take a damp filter paper and we place this inside. We take our vacuum pump and we connect start to add our Anthrocyanin extract and filter it. Did away with the filter paper because it was clogging up, it was too slow, but now it's sort of gone through. Not to worry. We're going to refilter this. Here is our cabbage extract. And here is our fibrous material. In order to concentrate this, we will need to perform a vacuum distillation with a water bath at 40 degrees. This will protect the anthrocyanin from overheating, decomposition and oxidation. Quite a bit of bumping going on. I put some shards of glass in there. I'm still getting bumping. Hopefully it will not reach the condenser. There may still be some non-polar molecules in here which I can extract using diethyl ether. Shake and bent. It seems like it's picked something up. I'm going to let it settle. Well, I think that is just unfiltered bits of cabbage fibre. Now here is our concentrated extract minus any non-polar impurities.
6.5 hours later.
I have collected 50 milliliters of the concentrated solution, and I'm going to store this with carbon dioxide. Replaces the air, preventing oxidation. It's not nitrogen or argon, but it's less oxidizing than atmospheric oxygen. And when it dissolves in the solution, it's slightly acidic, carbonic acid, and anthocyanins are more stable in acidic environment. This should preserve the color. From the rest of the solution, I will obtain anthrocyanin in a powder form. What does CO2 taste like? Tastes like fizzy water. Now we're going to end the episode with a repair of my heating mantle, which has stopped working. It is quite a common occurrence for a heating mantle like this to stop working. Also, when I replaced the sleeve last time, I replaced it with one that is lower power, doesn't have as many turns of heating wire, and so it will have a lower wattage rating. The first step is to unscrew these screws on the side. Now that all 3 screws have been removed, you want to keep the screws, and this section lifts up to reveal this. I have unscrewed the 2 wires. The cover can be lifted like this, exposing the insulation. Now you can remove the old mantle sleeve, as we no longer need this. Attached to the mantle sleeve you will find ceramic beads. These are useful to keep, or if it doesn't have any, you should get some. This sleeve can be discarded. Now you can take your new sleeve, this is a better one, and you can see there are 2 wires. We feed those through the holes. Now we have both wires poking through. I had to remove this little bit of insulation. This we can put back. Now we can use these ceramic beads to insulate the wire. Now we have the difficult job of attaching these exposed pieces of wire to these terminals here. First, we can put this back inside here. You need to straighten this as well. This was quite difficult to do because of the short wires, but I struggled and managed to do it. Now we need to change the fuse. A way we can do this we can throw this one out and replace it with a new one. Remember to get the right kind. Glass fuses. And this, for some reason, goes in upside down. And there we go, new fuse. All we need to do is to test. And it is working. The thermometer probe is not in at the moment, so it's not heating. We can test that. I use one of these PTFE temperature probes, and yes, it works. Regarding electronics, if you would like to learn more electronics, go to Successful Electronics.
Okay, hello everybody and welcome to this new video. I'm going to be talking about resistor.
Then I'm going to repeat the antenna and see if the range increases.
Make a temperature sensor project, or you want to make a humidity sensor.
You can learn a lot about electronics components, what they do and how to use them, how they work. Go and check it out. Oh, and here we have some steam coming off the mantle. Oh, that's nice and toasty. these new mantles, you sort of have to let this happen. Maybe turn it off for a bit and then do it again just to wear it in.